So hello everybody and welcome to another edition of JOGL Africa Community Series. We've had about 4 sessions this year so far. Today we are going to be talking about prototyping and digital fabrication with Dr. Babasile Daniel from GreenLab Microfactory Nigeria and also OpenLab in Hamburg, Germany. So just to introduce Babasile, he's an open source hardware evangelist who is passionate about boosting the awareness of open source hardware culture on the African continent. He is the founder of GreenLab Microfactory, which is the first fab lab in Nigeria. He holds a PhD in production engineering from the Helmut Schmidt University in Hamburg, Germany. His research centers around participative forms of technology, collaborative value creation, social innovation, sustainable development, and many other topics. I happen to have known Babasile personally through the Africa Open Science and Hardware Network. He's a very good friend and brother of mine. So at this point, I'll pause and invite Babasile to take over for today.
All right. Yeah, thank you very much. So I must first start with a little bit of a disclaimer. I've got cold, so my voice may not be clear and I might have to just drink water here and there so that I don't lose the remainder of my voice. So if you don't mind me sharing, I would like to share my screen. Where are we? I'm just looking for the presentation I made for today's session. Okay, there we go. So yes, so once again, thank you very much for the invitation to Gamali, my brother, and to JOGL Africa, and also for considering me to give this or to run this session. And I also would like to thank everybody for coming and making your time out to be part of this event. So like the question that Gameli asked, that has anybody used the floppy disk before? That was a good question, because I remember during my university days in South Africa, they were the things that we were using to save our codes when we, before we submitted our assignments. They were really little, but yeah, we used them. And also during my internship in Nigeria, I used the floppy disk for some periods. So yeah, good to know that some people never even saw it. But if you go to some art museums, you could find people making cool arts. I saw some in Saudi Arabia and some in Nigeria as well, making some cool arts with all this obsolete technologies. So we can really revitalize all those things. So yeah, the agenda for today, let me just do proper sharing, please. Oh yeah, so the agenda for today is just to give a little bit of emphasis on about myself, to introduce the GreenLab Microfactory, which Gameli mentioned some minutes ago, and to give you a quick tour of the OpenLab Humburg, where I'm also a manager. We have 2 managers here. I'm one of the managers that runs the project affairs of the OpenLab Humburg. Then we'll now dive into the full context of today, which is to talk about digital fabrication. And I will be sharing my basic understanding of digital fabrication after having run different projects across 3 continents on this same concept. Then we'll look into the basic digital fabrication tools. We talk about the digital fabrication techniques and the how-tos of digital fabrication. And in order to do this, because I want to make it a little bit practical, I will be making a quick CAD design for a keychain, which is what we used to do to introduce people to 3D printing concepts here at the OpenLab. So we just make a quick demo of how to make a keychain using the CAD software. And then I would also be laying emphasis on something that I've been working on, which is called effective rapid prototyping, which is a module that I've been working on here at the Helmut Schmidt University. Then we end up with some questions and answers. So proceeding, Gameli has already laid emphasis. My name is Babasile Daniel. I hold a PhD in production engineering at the Helmut Schmidt University in Hamburg, which is also known as the University of the Federal Armed Forces. So yeah, I teach soldiers. So you could imagine if your students don't I find it a little bit difficult to correct my students because they are always well dressed in military regalia, and me just having the fear of soldiers right from the Nigerian days. Sometimes when they make mistakes, I wouldn't even say anything because the fear of the military really makes me panic. So yeah, I work at the Helmut-Schmidt University as a research assistant, and I'm also the OpenLab manager, part one of my many roles. I also lecture here. I teach quality management to the final year students. And I also run different projects. Presently, I'm running a project in Tunisia, which is over €1 million that is based on starting open labs in Tunisia textile industry and also in the Tunisia technical centers. So I work on starting open labs or starting labs, and I work on it basically to ensure the sustainability of it and to do it in the context of the area or the locality where we are meant to run it. So if this project is a bit like complex like that, I am the go-to person they send for all these complex projects, especially running open labs in different places. I've run open lab in Palestine, I've run open labs in Tunisia, in Nigeria, and I've also had the privilege to do some projects in Saudi Arabia as well with some of my colleagues. So yeah, that's a nutshell. And I started the first fab lab in Nigeria called GreenLab Microfactory, which I would introduce to you next. And I think I should just go over there. So as you see on the bio, my, sorry, I think I need a little water. As you see on the bio, my research interest is mostly on the participative form of technology development. And by participative form, I'm looking more into the open source side of it. And by open source, we look into more how collaboration can be used to enhance value creation, mostly from the developing countries context. So that's my key area. And I also work on sustainable development and any other forms of open innovations or open source hardware that you might want to talk about. Then I tell you a little bit about GreenLab Microfactory. GreenLab Microfactory was started in 2017, and this is one of the reasons why Gameli and I became closer. So GreenLab Microfactory was started in 2017 because I was invited all the way from South Africa to Germany to work as a guest researcher to help do some research on, to explore the success rate of fab labs. And then I did my research in 2015, and being a very patriotic Nigerian, I looked into the country on the website to see how many green labs we had in Nigeria as of 2015, and I realized we had nothing. So I made emphasis, I tried my best to start one as at that period, but financial issues posed us so many limitations. But eventually when I realized the finances wouldn't come, I decided to start with whatever I had at that period, which was a fund of €800 from my present boss at the Helmut-Schmidt University. So we doggedly started in 2017, and we kept refining our approach in running the lab. And eventually in 2019, we launched our first node, which is called Green Garage in Akure in 2019, sometimes in September. And up to now, we have, like, because we are located in close proximity to the Federal University of Technology in Akure, we've got minimum 250 frequent users that comes to the garage, and we have done over 5 projects, 2 of which are community project, which is to build laser cutter, which is to build a solar panel, to assemble 3D printers, or to do any other community project like that in different areas. So we've run 5 different community projects up to today, and we are in the process of launching 6 different projects right now. 2 are already online. Maybe some of you must have seen the Lion's Den. One of the managers of the Green Garage, Bayo, was featured on the Lion's Den for his cool project called Traveler. So those are kind of the things that we try to nurture at the GreenLab Microfactory using our Green Garage concept. And the Green Garage concept is just to ensure that almost everybody within the 5-minute walk, they find like a prototyping center where they can go to bring their ideas into reality. And up to today, we have trained over 20,000 pupils across 9 different states in Nigeria. Then, before I go into this, let me just switch over to my phone and give you a quick tour of the open lab where I work. So here, as soon as you come in, you're gonna find our big CNC room. where we do some some machining using our BZT CNC milling machine. So we have like a chair here, but I think they've taken it to the Fab City house. But yeah, we mill things like chairs, tables, or different concepts. If you have like an idea like the open desk, we mill them here with our milling machine. And I also made some electronic components here as well. And right now, the noise you hear now is the noise from the laser cutting room. So in the laser cutting room, we've got the Trotec PD100. And as you can see, we are making, presently making name badges for an event. So this is our laser cutter. And we also got like the filament recycling 3 Devo. So this is a commercial filament recycling. So all the components from PETG bottles or the bottle caps, we take them together and we recycle to make filaments. And we've got our little electronic decks here and the vacuum thermoforming machine. And so this is the laser cutting room. And I promise you, this is the best room that I always use at the OpenLab. And you can see, and this is the OpenLab manager. His name is Ibrahim. Yeah. So here are some of the things we've done, some 3D models, some laser cut things that we have right now. And underneath here, you'll see some of the projects we have done in some of the innovation challenges that I've handled. This project was done by a guy from Mali. It's called Magi. So this project is used to test the water salination, this level of salt in water. We built it right here at the OpenLab, but we bought components online and we assembled everything together. And this is also a project from a guy from Senegal, Lily Kits. That's the name of the project. So this one recycles laptop battery with a solar panel to create electrode lighting for people in the villages. And this is also a project from Doji Honu, which some of you might know. Gameli definitely knows Doji from Togo. He came to the OpenLab to build a Pi comp using a Raspberry Pi with recycling old monitors to make that. So we've got some 3D designs that we've used, and this wall clock, we built this wall clock here. We came up with the concept of mixing 2 different components, 3 different components, wood and 3 different types of colors for the plexiglass together. And also we made this wall clock here, just testing out different things. And also we've got different types of 3D printers here. Some you will not see here at the OpenLab, but because of the complexity of these machines, we've got the multi-jet printer, which prints in different colors at once. And we've got the SLA, which I'll still talk about later. And we've got the SLS machine, which prints metals, but we don't have them right here at the OpenLab, but we've got them in another lab. So yeah, I will take you now to the heavy machineries room. Here you can see we've got the 3D printers here, not here anymore. We've got a smaller CNC milling machine, the Inzel, and we've got a giant 3D printer. So this prints almost 1 meter by 1 meter, no, almost 800 centimeters by 1 meter. And this is almost like maybe 8,000 euros. And from it, we were able to print this Eiffel Tower. So if you don't find me in France, this is the reason why I don't go to France, because I've got the Eiffel Tower here. So we've got different other machineries, the drills, we've got different kinds of drills. We've got the small electronic stations, and our lathe machine, our PCB milling machine, which I also have one in my office, and saws and things, and also another drill. And some basic work tools. We've got them here. And we've also got some handbill and things here that in case you want to work, nothing is stopping you. Everything you need, almost everything you need to run a fab lab, we've got them. So we are more like a super fab lab. Oh, hi, Pascal. Yeah. So in this room here, we've got lots of 3D printers. We have more than all these 3D printers right here. We've got close to 60 3D printers, but we've got different variations of 3D printers. We've got the Replica, we've got the Sigma, and we also have the Ultimaker, different variations to Extended Plus, Extended, Ultimaker 3, and other 3D printers. We've all got them here. So here is the most active room, because here we have conferences. but at the same time, it's very active because we also have lots of 3D printers, which is what people really want. And at the bottom here, you can see the little snap maker. So this snap maker is a 3-in-1 machine. You can use it for 3D printing. You can also use it for laser cutting, and you can also use it for small scale CNC milling. So he's an all-rounder digital fabrication tool, snap maker. So there we have some of the things that we've done here. We engrave on gift packages for guests, and also we make the lithography for guests as well as cool gift when they come over to the OpenLab. Let me just run this. Like you can see, this is a picture, but it was printed for one of our guests that came over to the OpenLab. So we do different things at the OpenLab. One of the main concepts is to bring your basic idea and to nurture you and give you an opportunity to turn your basic ideas now into a tangible product. So now this is my office. You can hear the noise at the background, so I'm gonna cut this as snap. So I've got my own PCB milling machine. I've got my 3D printer here, and I've got one that I built myself here as well. So I'm gonna log out from this one, then we'll go into the
You have to unmute yourself.
Okay, thank you very much. So I hope you were able to see the quick tour of the OpenLab. And like I can see questions from Alex saying, is the Eiffel Tower made of plastic? Yes, it was made of plastic, ELA plastic. So it took us over 36 hours to make. And the reason is because of the complexity of the connections in the Eiffel Tower. So if you take out some of those complexities, it could expedite the time or the print time for it. So yeah, that is a quick tour. If you have more questions, we can talk about it at the end of the presentation. So I will just go now directly into my presentation. Just pardon me, let me share once again. I am not the best at using Zoom, but I will make it work. All right, there we go. Can you all see my screen, please?
Yes.
Okay, cool. Then, okay, it doesn't work. All right, so now we go to the main topic. What is digital fabrication? So digital fabrication is a manufacturing process which uses computer numerically controlled machines to get job done. So in a nutshell, you have an idea. You want to build, let's say you want to make a chair. So instead of you getting your basic tools, your traditional tools of hammer and chisel and saw, what you just need is a computer and access to a digital fabrication lab, such as makerspaces and fab labs and tech shops. But I know tech shops has already closed down right now, but you can gain access to places that can help you. So digital fabrications are tools that enables you to bring your idea from the conceptual level, using a laptop, codifying it, creating the process on the laptop, and then working on it directly with a computer numerically controlled machine. Then we'll be talking about the computer numerically controlled machine in a nutshell. So I will talk a little bit also about the growth of digital fabrication. Everything we know up to today about digital fabrication was based on the result of the generosity and the good work from Professor Adrian Bova from University of Bath, who created a Replica 3D printer in 2004. And the concept of the Replica 3D printer is to create a 3D printer that basically recreates itself. As you can see in the picture, which I extracted from the Replica website, they created a website, a 3D printer that basically created another part for other 3D printers. So what they did here was just a fused deposition modeling machine. But right now, you have a 3D printer that could basically, you have the 3D printing capacity that could basically print everything you want, including electronics. but not the basic electronic components like the transistors, the resistors, and things like that. But it could even print the electronic board for you because you've got some conductive filaments that you could use. So what I'm trying to see here is the growth that we know of anything in digital fabrication was done from an open source side of it, which is based on the tremendous work from the University of Bath in the United Kingdom by Professor Adrian Boa. And also the growth that we know, everything we know about digital fabrication today is also due to the propagation of what we know as open source hardware. And the open source hardware comes in different places, just like the hardware itself, like the 3D printer that we're talking about, the RepRaps, the Cruiser, the different kinds of variations of 3D printers that you have. They are part of the reasons why we have a globalized world called digital fabrication today. And another part is the open source concept of electronics, Arduino, Raspberry, SparkFun. Those people actually democratized everything we know about digital fabrication, because prior to this time, digital fabrication was more for big people, more for big organizations, because thanks to RepRap, they were able to bring down the cost of a 3D printer from tens of thousands down to couples of hundreds. Without them, we would not have this democratized 3D printer like Cruiser, like Ultimaker, like MakerBot, BCN, Sigma, whatnot, Creality, Anet. We would not be able to have them. And for the fact that they created the democratized version of the 3D printer and made it open source, we have different companies that are now worth billions in dollars. So open source is the reason why we have digital fabrication. And we also have digital fabrication because of the software side of it, which we have the FreeCAD, which is a totally free software for anybody that wants to learn CAD. It's parametric. And also from the firmware, we have the Sprinter, we have the Merlin. They are open source softwares that you use to control the 3D printer that are released to the general public to use for free. Those are the reasons why we now can talk about digital fabrication. And another reason why we talk about digital fabrication as we talk about them today is because of the growth of movements such as Fab Labs and makerspaces. If you check anywhere in almost any country on earth, you'd find at least one Fab Lab there. And what the Fab Lab does is they create like an environment that has all the basic digital fabrication tools that an average person can go to and fiddle with and bring their ideas, no matter how stupid. And we always encourage stupid ideas because from stupidity comes the best things. So they allow everybody, no matter how stupid your idea is, to come, learn how to use the machines and bring your ideas to life. So in the basic nutshell, in Fab Labs, we don't help you to do your project. What we do is we train you how to use our machines. We show you our safety and security methods and how to make our office and our laboratories very clean. And we show you, after you've been certified on the usage and how to follow our security protocols, we now give you access to use our machines to do whatever you want, as long as it's not harmful. And in the Fab Lab, we also, at the OpenLab here where I work, we also follow strictly the Fab Charter, which shows what you could do in a Fab Lab, how to maintain the cleanliness of the Fab Lab, how you should relate with another person, and we also maintain a strict open source culture because we open our machineries to you for free. You are obliged to also teach any other person that wants to learn about what you are doing, but without infringing on your intellectual property, should in case you want to apply for intellectual property rights for your patent for your idea. So thanks to these three areas, we can now talk more about digital fabrication. Then I talk a little bit about the digital fabrication tools. So there are three basic machines that you must have and to say you are a digital fabrication laboratory. But it's not compulsory to have all the three, because digital fabrication laboratory, Fab Labs, makerspaces is not just about the machines, it's about the people and the willingness of the people to solve problems. So the basic digital fabrication tools that we always recommend for people to have or to have access to is, number one, the 3D printer is a buzzword right now. Everybody wants to use a 3D printer. Even when another machinery could do what they want to do faster, no, the only thing people want to use is a 3D printer, which is one of the bone of contention for today. I will be showing a little fast CAD design of a keychain for a 3D printer. And also we've got the CNC milling machine, which is the big one that you find outside. With the CNC machine, You could make wooden structures. You could mill aluminum. Some CNC machine could even do more than that. But in our facility, our CNC machine can only handle as hard as aluminum. And we have CNC machine. Our present CNC machine is based on 3 axes. But in Tunisia, we developed an open source version of a 5-axis CNC machine that could do intricate designs such as the Eiffel Tower, but it might take a long time. But we've already developed it, but it's not finished yet. And also, you must have a laser cutter. A laser cutter is the fun part of everything. Like right here in front of me, I've got a picture, a wedding picture of my wife and I, which I keep here. It was done from a laser cutter. And you can do a whole lot with a laser cutter. You can work on leather. You can work on cardboard papers. You can work on plexiglasses. You can engrave on glasses. And you can even engrave on stones. And you can engrave on aluminum, but you cannot cut glasses, aluminum, and stones, but you can only engrave on them, and even ceramics, but you cannot cut them. You can only cut as strong as foam material or plexiglass, and even leather. You can even work on textiles there at the laser cutter. And the reason why the laser cutter is the fun machine for me is because the transition from not knowing how to use it to knowing how to use it is really, really small, unlike 3D printer and CNC milling machine. Because all you just need is to know how to take a good picture, remove the background, and go to the laser cutter to engrave. And if you want to know how to cut, it's just a little bit of showing you how to trace out and how to change the color to the one that the machine understands. So the laser cutter is very, very easy to use. And another machine that I also always encourage people to get is a 3D scanner, because sometimes you want to make a design that is very intricate, that designing it yourself, maybe due to knowledge, might be difficult. And you have like a template that you could use. You could just basically take a 3D scanner and scan one for yourself. In the OpenLab here, we've got 2, and in other labs, we've got heavy 3D scanners that could do full body and even scan your spirit as well, but that's a joke. And we also have a vinyl cutter. So with the vinyl cutter, you could work on t-shirts or vinyl or any posters for your laptop, or even designs for mugs. And some things like this, you could work on all those with a vinyl cutter to help you. Then you can go into other processes to bring your concept to life. So in a nutshell, in a digital fabrication laboratory, what we do is we give you access to our tools and technologies and show you how to use them. And then if you need help, we help you to get everything rolling to achieve your goals. So then I will talk now quickly about the digital fabrication techniques. In digital fabrication, we talk about 2 different techniques. One is the additive manufacturing, and the second is the subtractive manufacturing. Excuse me, I just need to take a little water. So, just like the name says, additive manufacturing, you can easily just pinpoint that to 3D printing. When you hear additive manufacturing, it's also synonymous to 3D printing. And when you hear subtractive manufacturing, is CNC milling, laser cutting, anything that yeah, let me just go straight into it. Yeah, like in additive manufacturing are manufacturing processes that build concepts based on the right amount of resources needed. So in 3D printing, for instance, the machine uses the right component that it needs to build the stuff from different layers, one layer after the other. That is what it means by additive. It's adding one layer and goes to the next layer and goes to the next layer based on the G code, the gradient coordinate that the machine has translated your design to. So there are different types of machines for additive manufacturing. We've got the multi-jet that prints different colors at the same time. We've got the SLS, now the selective laser sintering machine that prints metal. So what it does in that situation is it arranges the particle and bakes it. So it levels it again and puts another layer of powder, iron powder, and bakes it again just to form your concept. But we have one here on the campus that belongs to us, but you cannot stay in the fab lab because it's carcinogenic. If you're exposed to it, it could cause cancer. And we also have the FDM, the fused deposition modeling, which is what everybody would be used to when it comes to 3D printing, which are the ones that print plastic that you can see in the picture right here. So the fused deposition modeling just goes to the exact G coordinate and G code location and deposits the plastic on that particular G code. Maybe is based on X and Y and Z axis. So maybe 001, it deposits the plastic, 00111, it deposits the plastic, and that's how it makes the layers until it gets to the height that you designed for it to do. So we've got different other machines as well. We've got the pancake 3D printer, we've got the pizza 3D printer, we've got the cake 3D printer, we've got even 3D printing machines that are being used to make human tissues and even for dental replacements. So 3D printing is all about additive manufacturing, and it's just based on adding one layer to another layer. So I will talk a little bit about when to use which concept when we get to the rapid prototyping. Effective rapid prototyping that I mentioned is a new concept that I've been working on. So I would just like to give you guys a taste of it. Then, in order to do additive manufacturing, you need to have CAD softwares, computer-aided designing software or computer-aided manufacturing softwares. So there are, like I mentioned, I'm a pro open source person, but I tried to be a little bit biased to include the SolidWorks because in the Fab Lab environment, we use SolidWorks because SolidWorks gives us free access to use the software as long as you are a Fab Lab. So that's the reason why I use them. There are tons of them out there. There is Keychain that is worth hundreds of thousands. But what I've listed here, the ones that I've listed here are the ones that you could basically have access to as we go, apart from the SolidWorks. So we have the Fusion 360, which is not free, but if you sign up for the educational license, you can use it for free. I've always been doing that since. And we've also got the Onshape. Onshape is also like Fusion, but the difference between Fusion and Onshape from every other part is because they are hosted in the clouds. Everything you do is hosted in the cloud, but you can still download it on your computer system. And the advantage of that is whenever, in case you don't have your laptop with you and you are in another geographical location, you can easily just find access to a laptop, log in your details and download, continue working on your design wherever you are. And you also got like the Blender. Blender is more advanced because it's not just for 3D printing. You can also use it for animation. And then you've got the FreeCAD, which is a parametric CAD modeling. I have not successfully used this FreeCAD before, but it's totally free. It's more free and open than Autodesk, Fusion 360, Onshape, and any other open source machine. But the reason why I have not successfully used it before is because you have to know how to set the constraints manually yourself, whilst Fusion 360 and Onshape does it for you automatically. So I always go for the easy option. I use Fusion 360 or Onshape for my project. But you've got tons of CAD softwares out there, but these are the ones that I basically fiddle with mostly. Then how to. So now in the how to, I would I want to make a quick. I think I can do this in 5 minutes. So let me create a new. Okay. Why can I see this one now? How can I take this one out of the way? Okay, yeah, I got it. Okay, now, so I need to just remove this zoom thing. It's blocking my view. Okay, now, so I want to make a quick keychain for demo purpose. So I'm using Fusion 360. Like I mentioned, when you open the Fusion 360, you can log in, enter your email address, do your registration, then you can have access to it anywhere. So now I just want to create, like the goal is to create a keychain. So like it mentioned in the I need to stop sharing my presentation so I can show you what I am doing right now. I don't know, maybe you can see my Fusion, but I will go back and share this second screen of the Fusion 360. Okay, yeah, there we go. So now, in the previous slide, in previous slide that I showed, they say you must come up with your idea. And when you are working on CAD, the best way for me is always very traditional. your pen and paper, and your ruler or any other thing that you want to use, to maybe a vernier caliper or anything you want to use to get the dimensions right. So because when you get the dimensions right, the product will look exactly like you designed it to be. So in my case now, I want to make a keychain of 60 millimeters by 30 millimeters with a thickness of 4 millimeters. So that is my target. And I also want the keychain to have a hole for the key ring. And I also want it to have a text called JOGL Africa. And I will do another one that has a text for instance, let's use Alex, another text, so I can show you just in a brief explanation how to make quick CADs. This is going to be fast, but when you come or when you fiddle with it, it might be a bit longer than that, but it's really pretty fast what I'm going to do. So now I know I want to make a keychain, a rectangular keychain of 60 by 30 by 4. So what I need to do is just to come to create. I have already clicked that. I go to rectangle, 2-point, 3-point rectangle, center rectangle. They are nothing different, but mostly I use the 2 points, so I can just drag out what I want to do. Don't freeze up now. So as you can see on the screen, the system has already shown me the exact measurement that I have right now. And on the blue highlighted part of 54.43, what I need to do is just to enter the 60 for that part, then click on the tab button and click 30. So as you see, once that is done, it's locking it for me. So I cannot change anything anymore with regards to this. So with regards to the height of 4 millimeters, we will do that after, we will do that now with, I can click on finish sketch, then go to extrude, or you can just click E. So once I click that, it's telling me, what do I want to do? So I want to create a new body. Then what is the distance of this new body? So if I just tilt my design a little bit, you will see it's showing me an arrow. So these are different methods of putting the height. So now I could easily just take this height and just do that, and you see the number is changing to 5 millimeters. Or I could take it back. So that's one method of doing the CAD design. Or in this box right here, I could just put my 4 and it will give me the exact 4. And also, when you are working on another object, okay, let me leave that till later. Let's just keep working. And so we have the height here, 60 by 30 by 4. So I click OK. So you see now, this new body is just showed now. So it just showed me this is body 1. When I click this, you will not see it again. It has hidden it. So if I now want to, because of the, after printing, you see these edges are kind of like very, very sharp. It could injure people. So what I need to do is make a chamfer or a fillet, so as to, what's the word for it? What's the English word for it? To remove the sharpness in that angle, to make it a bit what's it was spherical or arc-like. I don't know the word for it, pardon me. I'm not English, I'm Nigerian, so yeah. Or so let's just do the fillet now to remove the fillet of the model that we've created. So I just need to come. Oh, so I need to do a fillet of 2. Oh no, it's doing it on the wrong angle. I clicked the wrong angle. Sorry. So I need to click this particular boy. So let's make a fillet of 2. You see, I click OK, and I do that all around for all the other parts. Oh, I'm sorry, I don't really use mouse for this. I use my CAD design tools, so that's why I'm a bit rusty when it comes to using the mouse. And let me. So I just selected everything. So I've removed the angle now. Then part of our design, we said we want to make a hole in there. So if I want to make a hole, what I can do is I can create this hole right here, or I could go back to create sketch. So when I go back to create sketch, I can now draw a cycle, because I've already gone back to the initial state of it. I can now draw a cycle, put it anywhere, not anywhere, but based on where it should be on the structure that we want to work on. Then if you're not fine with that, you can easily just delete it. But yeah, let's just create a cycle somewhere here of 5 millimeters for the keychain, for the keychain ring, and click that. And when you click down here, you will see it has created another sketch, and this sketch is for this cycle. So if I remove this now, you see the cycle is gone out. So now what I want to do is to create the hole. So in creating the hole, I just need to select this, press my E or extrude. Then we know the height is 4. So I can, like I showed before, I could go for the arrow, look for that arrow. You can see my arrow there, and take it up is to add, take it down is to cut. And when you see, when I took it down, it shows -14, which means I don't even need to go for the arrow. I could basically just come here, click on my E to extrude, and I just click on the box for the dialog, -4, and it will cut for me automatically. So the joy of fusion and other parties, you could make mathematical equation. You could do -4 + 10 or +10. It will do the stuff for you. You see it has added 6 on top of it. But our job here is to create, to cut it. So it creates, it has already created a hole for us. Then another part of our agenda is to write JOGL Africa and to write Alex. So also we go back here again, we go to create sketch, then we come back to the create button. You see, when I click on create sketch, it created another sketch for me, which is sketch 3. You could basically name this everything so that you can easily follow and find, in case there are problems later on, you can easily trace it down to the origin of it. And in case when you start switching off, you don't forget the names. So now we want to create sketch, and we go to text. And the first text we want to enter, we just click on the surface where we want the text to be. We click on the surface and put the size of it. Now it's giving us the opportunity to write. So I'm writing JOGL Africa. And 5 millimeters is good. I can just move this a little bit somewhere. And what I want to do here is just to show you different options that you could have. Like now, I want to add this to the 3D design that we already have. So what I need to do is just to do my normal extrusion. I can either click E or come here after clicking finish sketch, click extrude, and select what I want to extrude. It has already selected the text for me. So now I come to the new body. You can see join, cut, intersect. These are different functions that you could perform when you're making your CAD design. But since I want to add JOGL Africa, I want it to be embossed on the design. I'm going to click join. Then I had the text for 2 millimeters, just for it to be obvious, to be well seen. So when I rotate, you can see JOGL Africa has been added to the screen of this. I mean, to the keychain that we already have. Then another thing that I also want to do is come here again. I click on, okay, why are you? Create sketch again. Then now I go back to text and enter and select the surface where I want it to be and enter Alex. And what I want to do with Alex is to cut it out from the original text from this board that we have. So I click finish sketch. After that, I select this, I extrude. After extruding, let's say I want it to go cut it by 2. So I just click -2. Then That is it. If you look at it, Alex has been cut into the board, while JOGL Africa has been added into it. So these are just the two different functions that I would like to show. Then afterwards, now what I need to do is to save my design. Save my design. My screen. Okay, I don't know why it's graying it out for me. Says expired, subscribe now. Yeah, but I should still be able to save. I apologize. I don't know why it's great. Maybe it's because my expiry stuff has expired. But yeah, when you get the opportunity, you just save it. And why did it grate out for me? Okay, so what I wanted to do before was to go to the 3D printer here to print something like this, which should really be done in 30 minutes, but it's not allowing me to save. It has really graded out for me. There's no work around it. There is no work around this for me. Okay, so I think I would leave the CAD stuff here and go back to the presentation, because I see I have 10 minutes more if I am right. So this is just a fast way of making a keychain. Then I will stop sharing this particular one, then go back into the presentation itself. Okay, share screen. There we go. All right, so now we're back. So like what you've seen now is from ideate, you design. From the design, you now prepare. And by prepare, we mean you convert your STLs, because when you save it as STL or STP. So because that's the language, that's the stereolithography is just like MS-DOC. It's just like the format for CAD designing, STL and STP. So you save it as STL, then you go to a slicer. You have different slicers. You've got the Cura, you've got the Simplify, you've got the slicer for Prusa, and you've got the slicer for MakerBot. But the cool thing is I use Cura because Cura communicates with almost all 3D printers. So I use Cura. So you go to the slicer for Cura, which I wish I would be able to show you, but I can't for the want of time. You go to Cura, you set your parameters for the wall thickness, the infilling, if you need to create infilling, 20%, whatever percentage you want, you create all those. After you've sliced it, then you can now go to the 3D printer and print it. And after slicing it, it converts the STL file now to the G code, which the 3D printer understands. Then you can now select the materials that you have that you want to work with. Then afterwards, it fabricates the concept for you that you've designed. Then it's left to you to do whatever you want. Maybe you want to go to the commercial, or you want to go to open source, which is the reason why I put the how to here. And the second part of digital fabrication is the subtractive manufacturing. So 3D printing is additive. Anything that takes from a big block a particular design out of it is subtractive. And when you think about that, you have a big block of, let's say you want to make a mug like this. In order to make a mug like this, you must have a big block bigger than this. Then from it, you make this mug. You can see that there is a lot of wastage. So this is the advantage of the additive manufacturing to the subtractive manufacturing. The additive manufacturing uses the exact amount in it to make this with minimum wastage, while the subtractive manufacturing takes a big block and mills this design that you've designed out of it. So it can sometimes result into minimum of 50% wastage of resources. And we're talking about a new era where people are talking about sustainable development. That is the reason why 3D printing is a buzzword right now. And for the subtractive manufacturing, you've got a CNC milling machine, CNC PCB milling machine, the lathe machine. Even the laser cutter is a form of subtractive manufacturing, because whatever concept you want, it's taking it out from a big block. Even the vinyl cutter could be categorized as a subtractive manufacturing, because out of the design you want, you are taking it out from a big concept from it. And now, which is the cool part, when to use what? And this is the part of effective rapid prototyping. So in 2-3 minutes, I will just talk about that, and how to know when to use one. And the reason why I came up with this is because I see in my lab here, what everybody wants to do is just to use a 3D printer. But meanwhile, based on my own knowledge and understanding, looking at what you want to do, I could really tell you, based on other factors like the usage of it, the time, the cost, the durability, the complexity, the material, the safety, and the aesthetics, I could easily just tell you which machine to use. So for instance, you want to make a prototype that you want to use directly. Like, let's say you want to make something for your injection molding from cast iron. So when you want to do something like that, and you don't have enough time to use the SLS 3D printer, you don't have enough time. So I could look at the complexity of it and tell you, okay, let's go to the milling machine and mill an aluminum for it. So looking at what you want to use it for, and the time you have, and the cost you have, we can use that now to tell you what kind of a machine you want, instead of just going heads on into 3D printing. And sometimes based on the complexity, like the Eiffel Tower, in case you don't have access to a 5-axis CNC milling machine, then definitely a 3D printer is the best option for you. But when we look at it, like when it comes to the usage of it, are you using it for something that would take on a lot of impact, or just something for demo purposes? If it's for demo purposes, I could easily just tell you, let's go to a laser cutter. We just need to spend more time making a vectorized design. Afterwards, where we just assemble it, and you can get it done within 1 hour instead of waiting for 36 hours to print. Or you can get it done with within a fraction of the amount it will take a 3D printer to do. So this is what I mean by effective rapid prototyping, is using the right machine for the right purpose, and with all other factors like time, cost, durability, security, safety, aesthetics, everything being considered. But right now, this is a concept I'm still developing, and I am trying to fine-tune it to make sure it's something everybody needs to learn. And presently here at the university, we looking into offering it as a module, because we have different modules on future of production and things like that. So yeah, and then if you cannot do CAD designing right now, but you have access to a 3D printer, you could go to these platforms to get like some 3D printable designs, like Thingiverse, Yegi printables. You can get free platforms. And also for laser cutting, you can go to Ponoco, you can go to DXF downloads. Well, all these areas for the laser cutting, you have minimal access to free designs. Sometimes you have to pay. But meanwhile, with printables and Yegi, you have more access to free designs, but you might, at some point, you might still need to pay for some designs that you want. So I'm about to close up now. So I'm just saying, if you want to prototype an idea, where do you go to? So from my own suggestion, from knowing JOGL Africa, I would say you go to them first, contact them. They might know somebody within your area, because they are a network of organizations that creates a connection between almost all organizations that is community driven in Africa and also in Europe. So they might know somebody that might help you. So I say go to JOGL Africa. And if you are adventurous, please feel free to contact me. My email address is there. And another thing that I would advise you is visit the Fab Labs website to find the closest Fab Labs to you. Unfortunately, in Africa, we don't have enough Fab Labs, but in Ghana, you've got the 4th Fab Lab in the world, which is the Fab Lab at Takoradi. And I know there is like this digital fabrication center at the Ghana Tech Hub also in Accra. And the Kumasi Hive as well could be a good place for you to visit. So what I would just suggest is go to Fab Labs. Fab Labs is the best place where you can find places to prototype. So you find a prototyping area in your country and you visit them. Another option is the makerspaces, but unfortunately, the makerspace website does not fully represent the amount of makerspaces we now have in Africa. That is why I would recommend more Fab Labs, because Fab Lab is always updated, while the makerspaces website are not frequently updated. And another option that I would also like to recommend is for you to visit the African Makerspace. They are also a conglomeration of makerspaces in Africa, though they are still very young. But I'm a member of it. But they can also help you tell you somebody that knows somebody or that could help you in getting your ideas done. So, and there is a friend of mine, T-Bot 3D printer, who makes a 3D printer in a box. So I spoke with him about the presentation I'm offering today, and he said, if anybody would like to get a 3D printer, he would be willing to give a 5% 3D, a 5% discount for a 3D printer, like a 3D printer in a box. So just imagine you are traveling somewhere. Instead of worrying yourself about a 3D printer, you could easily just buy a briefcase 3D printer and take it along with you and work wherever you are. So if you're interested in getting a 3D printer, I would like to interest you in T-Bot. Max, this is the 3D printer in the box, and also I have bought some for my lab here for some of our projects that we did in the past for the contestant of the project. And that is the end of my presentation. I would like to say a very big thank you to JOGL and Gamali, the team of JOGL in total, and also to say a very big thank you to every one of you for your attention, and I hope you enjoyed the short presentations that I was able to scoop in a short while. So thank you very much. I would, if you have questions, we can talk about it now. So I'll stop sharing. And my contact details are here. So I don't know, maybe Gameli would allow me to keep this stuff there in case anybody wants to write it, or I can put it in the chat section. So I would stop sharing now. Thank you very much, everybody. Thank you.
Awesome, Daniel. Thank you very much for your great presentation. I think it's been fantastic, fantastic presentation. We've learned a lot. I think for me personally, the main thing I've learned is the difference between additive and subtractive manufacturing. Additive manufacturing, I have to tell you, additive manufacturing has to do with using the amount of material that you need to make whatever you make. And we are talking typically of 3D printing and subtractive manufacturing using some of the other technologies like laser cutting. And then you make it out of a block which is less sustainable. At this point, I think I'll just open up to questions. I'm going to be going through the chat. There are lots of questions that were asked. So I'm going to be going through the chat and then I'll be raising these questions. However, if anybody on here would, you have new questions, or even if you asked in the chat already and you want to ask a question, feel free to just use the raise hand feature, and then we'll allow you to ask your question to Daniel directly. Otherwise, I'll be going through the chat.
If I may just say something quickly, I can see Alex saying he's really terrified. That is not what we do. We are mostly excited at the Fab Lab than being terrified. I don't know the context of being terrified that you meant, Alex. So maybe if we can clarify that, that would be good.
Thank you so much. I made that it was really intense for me, that it took me by the storm. That's what I meant, like it's extraordinarily good. It's the terrific that I meant, not the negative one.
No, thank you. No, because normally when you come to the lab, it's much more fun than I made it look. It's crazy fun. It's all about fun for us. So
indeed, it's really fun. It's really enjoyable.
Yeah.
Okay.
Thank you so much for the great work, Babasile.
Okay, so there's a question from somebody, Mahmoud. He's asking if you're a robotics engineer.
I don't classify myself as an engineer. I'm a maker, so I am not limited. I can do engineering things. I can do robotics because I've got the Fab Academy certifications. I can work on electronics. And if I cannot, I've got connections to crazy people that could. So which is what the makers enjoy. We are not, few are engineers. A lot of people are engineers, only few are makers. So I classify myself as part of those people who are makers. We are not limited. If I cannot do it, if Gamele could do it, I will go to Gamele. And if Gamele could do it, that means I can also do it, because we are working on a collaborative network. So this is what you enjoy from being makers.
Awesome. Okay, there's a question from Benjamin. I'm not sure if he's still here, but he says that besides small-scale applications like robotics hobbies, have you been able to deploy it on a large-scale industrial basis? Or what are some of the examples of companies using additive manufacturing massively?
Yeah, there is, that's a good question, because we have like millions of companies using it. Like in Dubai right now, they're trying to create like building structures, even hotels, using 3D printing. So there are 3D printing houses right now in Dubai. And also we have the open vehicle, open car, that are printing cars instead of just molding and casting everything. They are printing them. So there are different billions or multi-billion companies doing 3D printing. And also you have 3D printing on an industrial scale, like 3D printing farm, where you have access to 3D printers, 10 3D printers, 5 3D printers. You could start a business of 3D printing for people, taking businesses and printing in larger scales for companies and different things. So 3D printing is still growing. And also, like I mentioned, in the medical field, that is a critical part. So there are different ways of applying 3D printing. Medical field, construction, civil engineering, whatever ways 3D printing is being used by big organizations. But the cool thing about the big organization is the fact that we are democratizing 3D printing, because now from the big 3D printer that I showed you cost between 60 to 80,000. An average person cannot have access to that. But it's still the same concept of fuse deposition modeling. Meanwhile, you could make something of that gigantic size from an open source 3D printer. A friend of mine in Norway built a 3D printer that cost 350 euros that could print something bigger than the 80,000 euros could print. He printed something he called the Tower of Babel. It's called a hang printer. So it hangs it, you can print based on the height you could suspend it. So 350 euros that could print bigger than 80,000 euros. This is the world of open source. And that is why we try to get people to understand open source. Everything is open source.
Awesome. Okay, the next question is from Mousy. He already has it here, but Mousy, since you are here, why not turn on your mic, possibly your video, and then ask the question directly? Hello, Mousy.
Yeah, thank you very much. Please, can you hear me?
Yes, we can.
Okay, so my question was whether Babasile was connected to the Fab Academy. I've been hearing on the Fab Academy for a while now, and how possible it is for someone in Africa to joining those one of.
Yes, unfortunately, it looks like Mousy is having.
No, I understood his question. There is a jovial part of it. I think
okay.
He's using a floppy disk, so that is why it's a bit slow. If Mausi can mute, I can respond to your question. I understand what you're trying to say. So, like I mentioned, I think you were probably using a floppy disk, which is 1.44 megabytes. It cannot handle the bandwidth. That is why it's a bit slow. I'm sorry, it's a silly joke, but yeah. So, with regards to the Fab Academy is the coolest thing after PhD. So, I would say I'm a Fab Academy graduate, and I always say to people, it's much more harder and much more difficult than my PhD, which took me 3.5 years. And because the reason is Fab Academy is like a BSc degree, 3 years BSc degree program that you have to do within 6 months. And it's not just theory. You have projects, 22 projects to do within 22 weeks. So Fab Academy is really possible. One thing you must understand is you must have a Fab node, a node that has access to all the digital fabrication technologies. laser cutter, 3D printer, milling machine, vinyl cutter, electronics production systems, and things like that. If you don't have access to any node that has those basic fives and even a 3D scanner, you cannot successfully finish your Fab Academy and you would really struggle. But if you can find a node, like maybe Ghana Tech Hub could be a good node. If they can get a 3D scanner, I don't know, maybe they have one now. So if you can find a good node to act as your Fab node, you can do Fab Academy. And I would always encourage anybody that wants to become a maker, that wants to really challenge things, to do Fab Academy. But I always put a disclaimer, it's tougher than it sounds, but everybody can do it. It's fun. And you are being taught by the founder of Fab Lab, which is Professor Neil Gashenfeld. So you're learning from the genius himself, and you'll be connected to crazy good instructors that are very friendly all across the globe to support you. So what you need to know is you need access to digital fabrication technologies. And also Fab Academy costs $5,000, which is the part that is not cheap. But sometimes there are scholarships. So if you can express your interest and go to the Fab Academy website, express your interest, or there are sometimes they advertise some scholarship schemes. You can apply for them and express your interest and make sure you have a strong point why you should be given. And yeah, I would always recommend Fab Academy for anybody that wants to learn how to make almost anything. So I hope I have answered your question, Mawusi.
Thank you very much, Babasile. So now there's another question. I think this time is from Fasil. Fasil, do you want to go ahead to ask your question? Okay, I'll ask on his behalf. He's asking if there's a difference between Fab Labs and makerspaces. And if there's a difference, how do you turn makerspaces into Fab Labs?
Well, there is no difference. Technically, there are no differences because we are talking about spaces that have the same concept. I mean, the same machines. But the thing is, when you go to the Fab Lab website, you see makerspaces registered on the Fab Lab website. When you go to the makerspaces, you see Fab Labs registered. So the only difference that, from my own understanding of interacting with both and doing researches on both, is just the Fab Lab charter. We have something that governs us as a Fab Lab, which is like some of the do's and don'ts. You are eligible and you must teach others. As long as you are within a Fab Lab, you must teach others that wants to know about your concept. While some makerspaces, you could have something like Chaos Computer CCC. They have different
club.
Yeah, Chaos Computer
Club. It's a German organization. It's very interesting if I like them.
Exactly. So you have different sectors. You have some people that you are not limited to what you can do at the makerspace. Well, the difference from my own context is just the application of the Fab Charter, which is at the makerspace, there is nothing really governing what happens there. We have this governing body, and we've got the Fab Academy that trains you. Meanwhile, in the makerspace, I have not seen any certification, so to say, that you could use. So there is no difference when you check the fablabs.io, makerspaces are registered. When you check the makerspaces.com, Fab Labs are registered. But the difference is just the application of the Fab Charter. That is what sets us apart.
Okay, thank you very much. I think that just to kind of ride on your answer, I think the most important thing is this open ethos that many of us are promoting, whether you are looking at hardware, you are looking at other kinds of projects. We've learned so much, for example, from the software community with their open source software. And so they've inspired a whole lot of things, even within doing research and innovation. This community approach, this open approach, I think it really helps. It helps things to go a very long way. Thank you. Do we have any more questions? I think I've read all the questions that are on the chat. I think that's it. Alex has another comment. It says, fast technology, I'm really happy to be a scientist at this moment. Yeah, it's true, there's a lot. So yeah, just to round up, I'd just like to say a very big thank you to Babasile. Let me just take a little bit, the last few minutes of your time to share a bit about JOGL. I think some people are asking about what we do at JOGL. So let me just share some quick information with you, if you oblige me. Okay. All right, so just to explain JOGL a little bit for those who might not know about JOGL, we are basically a digital platform that's interested in supporting communities that want to execute their own science and innovation projects. So apart from, we have our platform, I've already shared a link in the chat, app.jogl.io, through which individuals, groups, and organizations can create their projects or create spaces to represent their organizations and sort of like promote their activities online. We currently have about 7,000 users around the world, which means that you also get to connect to the global community of problem solvers, makers, innovators, etc., which makes it interesting because then you get to receive support in case you need certain types of support for your project, but you also get to participate in various challenges and programs and things that we come up with at different points in time. All of these challenges are geared towards solving specific problems, either at the regional level or globally. So we are in essence helping to achieve the SDGs. So like I said before, it's all about community, it's all about creating impact, it's about solving global challenges. And what we want to do is to break silos. So we don't want only people in academic institutions or people in big companies to be part of the research and innovation process. We want everybody to be part of the research and innovation process. So whether you see yourself as a student or as an expert or as a researcher or scientist or an activist or an innovator, you are welcome to come on JOGL to also connect with other people who are like you, who share the same principles and ethos as you, ethics as you, but at the same time, people who are different from you in terms of differences in skill sets or backgrounds, to work together as a global community. And so within this, we have the JOGL Africa initiative, specifically oriented towards science and technology development in Africa. Currently, through our platform, we host a number of African initiatives and organizations. JOGL Africa and partners started, for example, the Africa Against Antimicrobial Resistance Initiative to combat antimicrobial resistance using the community approach. It's a very humble effort, but we are growing it gradually. We host other organizations, for example, Africa Archive, Africa Open Science and Hardware, Symbio Africa, all of these different types of communities we host on our platform. And we'll be happy to also host communities that you also lead on JOGL if you're interested. Like today's event, we also host other events. So the last event prior to this one was on biosafety and biosecurity. And subsequent months, we also organize other events as well. We've organized events, for example, on robotics, on community science. Last year, we had other types of events on science communication, a virtual skills camp, talking about different skills, etc. So just you can join our meetup group so that you get updated on the events that we are going to come up with. So I was explaining our antimicrobial resistance initiative earlier. Basically, it was a three-pronged process. We helped to provide capacity for students and lab technicians on AMR through a curriculum that we built. We also supported the creation of an app called Microbis, which was an interesting way to collect data on antimicrobial resistance in different places. And then finally, we did an innovation challenge using our community-based open peer review system, which means that every participant in the challenge is part of the panel. So we don't rely on small panels. We do it as a community. And through that, we supported one project in Nigeria to undertake research and education activities to fight antimicrobial resistance. So this is like the pilot program that JOGL Africa has initiated. But going forward, we are looking to come up with also programs to address plastic pollution, for example, plastic waste, for example, and also things like air pollution and other challenges. So the next thing that is coming up in the JOGL world is actually just on Friday, we are organizing a global summit, which is looking at the community approach to research and innovation around the world. So you are cordially invited to be part of it if you've not already registered for it. It's called the Just One Giant Summit. It's going to happen on Friday. We have a special track focused on Africa. So we are going to be talking about different African regional issues as well. But apart from this track, we have a track on open source or open science hardware. So I think that this is something that might be interesting to many of you. We have a track on community labs. So this could also be interesting to some of you. I am having a background in environment and health, so I'm hosting another track on environment and health. So assuming you are interested in how do we use the community approach or how do we use technology to address environment and health issues around the world, you are welcome to join this track. And actually, there are so many different tracks that may match your interest. So I hope that we can share a link to the event for you to register if you're interested. And Alex, please drop a link to it in the chat for us. Yeah, so this is the link. You can go to this link, bit.ly/JustOneGiantSummit. I think I'll drop it in the chat. These are some of the speakers that will feature at the summit. And you can see that some of the speakers are also from some of the organizations that have been mentioned. For example, Gertrude is from Africa Makerspace Network. Frank is from Africa Open Science and Hardware. We have Peter from Symbio Africa, etc., etc. So it's going to be a really, really interesting summit on Friday if you're able to join in. I'll just like to say thank you so much for coming, and feel free to contact us at JOGL. I will drop my email as well so that you can reach me directly if you want. And looking forward to partner with all of you going forward, and looking forward to having you at our future events. Thank you.